Okay, we finally have the elusive, sought-after, prized possession of the list of possible reasons in a proof. I know we have talked about getting this in class, and some of you have been asking for it, and hopefully this will cover pretty much everything that we are going to do. So let's jump right in. First things first, when we start with a proof, everybody should be yelling out, we start with the given. Okay, so let's zoom in a little bit so it'll be easier for me to write. All right, let's write our givens in there. We have y is the midpoint. We have y is midpoint of xz. Okay. We have AY is congruent to BY. And we have angle AYX is congruent to BYZ. Alright, now I'm going to shrink all these so it doesn't look as ugly. I'll tell you, it's tough writing on a computer screen, but we will fight through. Alright, so now that we've got all of our givens, we can take a look back at the picture. Or I guess take a look back at, we want to take this, let's take given over there first. Alright, so given is the answer to those first three. Alright, so let's go ahead and label what we know based on the givens. So it told me that AY is congruent to BY. Alright, so we got that in blue. AYX is congruent to BYZ, so those two angles are congruent. And it told me that Y is the midpoint of XZ, which we will define here in a minute. Or not define, we will use here in a minute. Okay, so we know that the midpoint means that it cuts a line in half. So we should be looking up here and see that XY, right, must be congruent to YZ because Y is the midpoint. Okay? So let's write what that means in terms of a statement. So we can just say XY is congruent to YZ. All right, and that is so because, and the giveaway is this bolded word right there, midpoint, so we can just put in definition of midpoint. Okay, now that we have that, once we have labeled it, let's get it into the line if we know that these are true. Okay, this is going to be a short and quick proof. Because if you're looking at your two triangles, you should see that we have side, angle, side. All right, side, angle, side. That's an order that we like. All right, and this problem is trying to prove that the angles are congruent. Probably should have had that on here, but that's okay. They wanted us to prove the triangles are congruent, and we're about to do that. So we can say that triangle AXY is congruent to triangle BZY. And we can say that that is true by the triangle congruency property of side, angle, side. Okay, so let's drag that guy over here. And so that problem will be done. Okay. Once we have enough information to prove that the triangle fulfills a congruency theorem, we can just say that that they are congruent. All right, problem number 2. This one gives us that two lines are perpendicular. So not perpendicular, excuse me, are parallel. WN is parallel to HK. So I think it helps us when we extend these lines a little bit. So I'm going to try to extend them just so we can see stuff a little bit better. That's an ugly line. There we go. Okay, so hopefully that'll help us see a few angles that we're going to need to see to solve this guy. And let's start with our givens like we always do, and there's only one here, so WN is parallel to HK. Okay. And the reason for that is obviously it is given. Okay. So, first things first, it doesn't give us anything else other than that, so we're going to have to work some magic here. Okay. And we should see that angle KZH is congruent to angle WZN. All right, and those are vertical angles. All right, so angle KZH is congruent to angle, what was that, WZN. Okay, and that is true because they intersect at an X. That's how I remember vertical angles. If they intersect at an X, these are vertical angles. All right, so let's take vertical angles and move it over here. All right. If those are vertical angles and these are parallel lines, then we can find that this angle here is congruent to this angle over here. Okay, and those are inside of the Z. I imagine there's a Z. All right, the armpits of the Z are congruent, and another name for that would be alternate interior angles. Okay, those are alternate interior angles. All right, and those angles are NWZ. Angle NWZ is congruent to angle KHZ. Okay, and if those are alternate interiors, then we can say the same thing about these guys. That those are alternate interiors as well. So we're actually going to have two pairs of alternate interior angles. Okay. And this second pair is WNZ. It's congruent to angle HKZ. All right, and so we've proven that they have three angles in common. All right, and we want to prove, are these triangles congruent? All right, so before we reveal the answer, let's just talk about if they are W and Z and HKZ. All right, are the triangles congruent? Okay, so let's take a peek over here at our congruence theorems. All right, it's not side, side, side. All right, it is not angle, side, angle. It's not side, angle, side. It is not angle, angle, side. And it's not hypotenuse, leg. Some of you would want to write, a lot of you would want to write angle, angle, angle. But this actually does not prove congruency. Okay, so this triangle is actually, we are unable to prove that it is congruent. So we would say, we would come in here and nicely write, not enough info. So the solution here cannot be determined because of angle, angle, angle. We don't have enough information. And you're probably like, why would I do all of this work just to prove that? And you're probably mad at me right now, but we need the practice of just continually doing these problems, seeing the thought process behind it. And being able to prove why they're not equivalent is just as important as proving why they are equivalent. All right, let's do one more problem. before I bore you to death. So we've got our given statements. So let's do our givens are JA is perpendicular to MY, and YM bisects JYA. Alright, and you'll recognize this problem from class, our two given statements. Alright, so let's use the definition of what we know perpendicular and bisect means to hopefully help us out here. So we can start with the definition of perpendicular. That should tell me that this line MY and JA, they make two 90-degree angles right here. So 90 degrees and 90 degrees. Okay? So I can go ahead and say that the angle JMY is equal to 90 degrees, and angle AMY is also equal to 90 degrees. All right, and I can do that by the definition of perpendicular. Because both of these are 90, we can say that these two angles are equal to each other. Okay, so angle JMY is equal to angle AMY. Okay, and that is true because of the transitive property. All right, if they both equal the same thing, then they must equal each other. So we call that transitive. Okay, so let's go ahead and put that onto our. We've already got that on there as the blue right there. All right, let's use that bisects. So YM bisects JYA. So that tells me, by definition of bisects, that angle JYM must be equal to angle AYM. And that is simply just the definition of bisect. Okay, so let's put that onto our triangle. Put it up there and there. Okay, whoops. Alright, so we've got an angle and an angle, and lastly, probably the easiest one, that you can choose to do these in, whoops, you can choose to do these in any order. But it just so happened that ours, I do not know what's happening. It just so happened that we did ours in this certain order, but again, you can do any of these in any order. And if you notice that the two triangles, they share a line. They both share side MY. So we can say MY, well, it is congruent to itself. All right, and that is the reflexive property. Okay, and so we can go up here and say that we have a side there. Okay, and we can say that these triangles are congruent by angle, side, angle. Okay, and y'all can write that last step.